This is Innovating Leadership, Co-Creating Our Future. I'm your host, Maureen Metcalf, the founder and CEO of the Innovative Leadership Institute, where we help leaders become future ready. Today, I am delighted to have Greg Moran joining us. Greg is a coach, executive advisor, and board advisor. And today we're going to be talking about how AI is evolving and impacting organizations. So, Greg, you've mentioned that over the last few weeks, how the app dev world has changed dramatically. Can you talk about those changes and why it matters?
Yeah, absolutely. It's interesting when you look at the arc of technology evolution. There are often things that sort of have been out there as a promise for a really long time, and then when they arrive on the scene, they can arrive kind of suddenly, and that's a little bit of what's happened here. We've talked for years about the idea of using AI and AI-assisted coding to really help accelerate the work of developing full-functioning applications. And there's been little bits and pieces of it, and there's been fits and starts and some progress made. But in the last 3 to 4 months, there's been rapid acceleration as the AI companies have really shifted their focus from building out better models to building out application ecosystems off of those models and working closely with other companies that are developing tooling to help automate the development of applications. So specifically some things that have really been game changers. One, model context protocol servers. So these really hit the mainstream late last year, and now we're seeing MCP servers delivered almost on a daily basis. And an easy way to think about a model context protocol server is that it's an abstraction layer between an application that you may be trying to write and the various APIs that you may want to integrate with. So think, for example, if you wanted to build an application that knew how to talk to Salesforce, knew how to talk to Oracle databases, knew how to talk to ServiceNow, and knew how to talk to, any other set of commercial applications that we all know and love that are in the cloud. An MCP server already knows how to interact with those APIs. So you don't need to know that anymore. You just need to know how to talk to the MCP server, and the MCP server will translate your prompt or your request into the calls that need to be made to all these various different services that you're interested in interacting with. That alone is a huge game changer. And then when you combine that with automated tooling on the front end that allows you to simply do what's called now vibe coding, where you're creating a thoughtful prompt for your application development environment, usually tools like Cursor, and there are many others that can just take a prompt and they'll generate all the code for you using various different models like those from Anthropic, those from OpenAI, et cetera. So now you're sitting there and you simply put in a prompt, and within seconds, you've got all the code, and you can test that code in real time. And then you can go back and readjust your prompt and make it a little bit more specific or tune the outcome. And you end up with, in the space of maybe an hour or two, a really good working app that you can then sort of do the things you need to harden it and get it deployed as an app in the world. And that's a real game changer.
For those of us who haven't developed apps, how long did it take previously, and what kind of funding, level of effort, time, cost?
Yeah, you're pointing to one of the things that I think is going to be really rethought, and that is the whole concept of seed rounds in the tech startup world, right? So the concept of a seed round was typically that you had a great idea, but you needed enough money to hire some programmers to develop MVP, or minimum viable product, something that could be tested, that you could potentially try out on a couple of likely customers and see what they thought of your idea. And that oftentimes is months and months of work. So you might have a seed round of a few $100,000 or even a couple of $1 million to get your MVP built. I think I think that kind of goes away in a lot of cases. Not every case, but in a lot of cases, you're now in a situation where you don't need a seed round. You can bootstrap the company to the point where it's at MVP and simply be looking for investment to do the things that you don't know how to do or don't have the capabilities and network to do, things like setting up distribution for your app. So it really accelerates and changes the economics of the startup world, particularly the tech startup world, in a profound way. One of the things I read just tail end of last week was that 25% of the tech startups in the Y Combinator, which is the largest incubator in the technology world, have code bases that are 90% AI generated. I think that number is going to be going north rapidly over the next few months.
I understand for the startup world, this is an absolute game changer. For people working in fields that aren't tech based, why do we care? How does it impact us?
Every company today, even a company that is not a technology company, typically is going to have a set of applications they rely on to run their business. And, if you're a medium sized business in today's world, the preponderance of those apps are going to be cloud based applications that everybody else is using too, because that technology isn't what differentiates you, right? If you're a services company or a process manufacturer, or even a discrete manufacturer, you've got some standard apps that you're running for your MRP systems and your accounting systems, et cetera. But the bulk of those businesses, even medium-sized business, have a couple of things that they do that are unique, that differentiate them in the marketplace. And oftentimes, around those unique capabilities, they've built up some homegrown applications that help them continue to be able to innovate in a way that separates them from their competitors. Even in that space, this is a very relevant conversation. And even if it's using very proprietary technology, because now you can purchase proprietary large language models that are uniquely oriented towards your industry, and you can run them privately so you don't have to worry about IP, and you could hook them up to these application development environments that would allow you to then iterate way more rapidly on the capability that you have in house. If you grow that up to the enterprise space, you're in kind of usually a different sort of problem. So at the mega enterprise space, you typically can't be served by the generic sort of cloud-based application platforms. And so you have a lot more custom code in-house to integrate all these systems and to add custom features to it. What I see happening now at the enterprise level is the ability to deliver features on a time frame that enterprises just aren't used to. You can deliver something in days that used to take months. So the whole concept of business analysis and a product function in the company begins to go away in light of the fact that the long pole in the tent is really figuring out what you want to do, not the building of it. And it used to be the other way around. We spent a lot of time making sure we really knew what we wanted to do before we started building it, because it was really expensive to build and deploy. What if the build and deploy cost becomes the smallest piece of the equation? And now it's really about making sure that you are enabling your organization to iterate very quickly and do experiments that allow you to, using a very practical and a very real prototype, evolve your way rapidly towards what the next solution is, even if that means cutting off an entire branch of code and replacing it with a new branch of code just to get access to one new feature, because the newly generated code may be way better at all the things in that particular functional aggregate than anything you've built previously.
So, what it sounds like, or at least what I hear, is the coding is easy or much easier. And yet, through the lens of an executive, I'm still trying to run my business more effectively. So, I may have better code, but now I have processes to change. Humans have to behave differently and function differently to meet my end users need or their stakeholders. So now it sounds like the long pole in the tent goes from the actual app to the humans who are needing to be a lot more agile than they were previously.
It could well be, although in my experience, when you are trying to introduce change, particularly at the enterprise level, the people who are the ultimate recipients of the change, while they may need some change management, they may need to be
Hmm.
trained on the new application or whatever it might be. They generally have been desperate for the change for a long time, and they've been waiting in a backlog of things getting justified and business cased and developed and tested. And so I think what you'll do is you'll find that organizations are able to evolve way more rapidly. And to your point, I think it's going to put more pressure on people to be thinking of what are the things that we could do to be better as a company, because the barriers to introducing that change are getting lower and lower every day. So that agility has to go up, but it's beyond the agility that's about just absorbing change. It's now you need to be a change agent if you want to be an effective part of this company, because you're at the front line. I don't need you just doing. I need you telling me what doing better
Hmm.
looks like, because I can get that
Well,
for you fast.
for some, this is absolutely a welcome change, and for others, that that speed of changes is not comfortable.
I 100% agree with that. The days of being able to say, I've learned how we do this thing, and I'm just going to be the person that does that for the next 20 years until I retire, I think that's gone. There just isn't going to be a tolerance for standing still, because the barriers to figuring out how to do it better are just getting lower and lower and lower, right? The unit economics of
Hmm.
improvement are getting really, really good, right? I mean, I look back on things like, do you remember how much energy it took to decode the first human genome? And now it's a minute, right? Like it's literally a minute, and very little compute power because we've completely changed the unit economics. Now imagine, that progress took several years. Imagine now with the tools that we have, including ever expanding compute power, ever expanding compute models, and you look at things like quantum computing that are just coming around the corner, and the ability to do more computing in a minute than even our most powerful capability today can do in days and weeks, right? Like it just becomes a different sort of a ball game to be a knowledge worker, right? And the knowledge worker is really the person who is conceiving of what's next, and to use the vernacular, sort of vibe coding their way to that next place very quickly, and then validating that they got it right very quickly or evolving it very quickly, right? So now you're in very rapid change cycles.
So we've got uh, pharmaceutical distribution, we've got insurance, and we've got manufacturing. How do companies like that take this idea and quickly become more effective at the enterprise level?
In the case of insurance, insurance is increasingly, focused on putting capability in the hands of the policyholder, right? And let's say that historically you've had an app that you do a new release on the app twice a year. What if you were releasing new capability on the app daily, right? What if
I
you
don't
were
I don't know as an end user if I want to have to figure it out every day when I go on it.
okay? So you got to be smart about how much change you introduce. But I can make a small change, and deploy it to you, and this happens today. It's called A/B testing, and I'm going to release a certain feature a certain way to some users and a certain feature to other users. But now the lead time to get those features built is really, really low. So you could be doing that type of testing at a much, much more rapid pace, right? Because, a company the size of Nationwide or a company the size of Cardinal Health, they're going to build out their own MCP servers. And so now developers don't need to know how to talk to all those apps. And the MCP server is tested so that they can trust that any call that goes against that MCP server is going to be handled properly on the other side. So I don't have a lot of testing lead time, and I don't have a lot of things that have to be checked and double checked. You're just focused on trying. And if you get feedback that says, the 200 users you tried that feature on hate it, it's gone tomorrow, and there's a better version of it. At a company like Cardinal Health, when you're looking at systems that are used to optimize very, very complex supply chains, and introducing change into that world is very hard. Imagine change being able to be introduced into that world much more easily, because you've got these layers of abstraction that allow you to simulate what it might look like very, very easily, when today that's very difficult to do.
So I can update the backbone infrastructure then that runs not only a small company, but a large complex company in relatively short order.
Yes. And it doesn't mean you'll choose to deploy that, but you can experiment, and the barrier to doing the experiment is so low that it becomes worth doing, right? Like if the experiment's going to cost you 6 months of coding time and a team of 10 programmers, and it's going to be, and you've got to build a business case for that's going to, likely justify spending $10 million on this potential change, and you change those economics to, we could try this potential idea out in a week and put simulated data through it and see if it performs better than the existing system. Now the unit economics of experimentation go way down. Sort of like you can look at it a macro way in the physical world with what Elon Musk has done with rocketry. When you reduce the cost by 100x and then by 1,000x, you now can be experimenting with things that we used to never even contemplate experimenting with. Like, he doesn't mind if a booster blows up, because the booster doesn't cost that much relative to the revenue stream of the company and the potential revenue stream. Where it used to be, if you lost a booster, that was the end of your company. So it wasn't a measure twice, cut once. It was a measure 1,000 times, right? And cut once. Well, now it's, no, that's my iteration. So if you've been following like his new huge big rocket, he's blown up, I think, 6 of them now, right? And he's unconcerned. Like, he posts on there, he's like, yeah, we got way further than I thought we would this time. We learned so much. The next one's going to blow up much later in the flight, right? But it's because unit economics are so different.
Mm-hmm.
That experimentation makes sense in a place where you never used to experiment. Same thing is happening in the application development world. You can now experiment in places where before you would have never experimented.
So does this solve the question? I'm thinking of large legacy companies, again, the ones we mentioned, and or any other large legacy company that has, let's say it would take $1 billion to replace their legacy system. So fill in the blank company has built custom systems over the last few decades. Does this now start to help those companies compete with newer, more nimble companies?
It's going to be a very hard mindset shift, which is why it's worth talking about, because it's going to take a while for people to really believe, right? But if I were at a large enterprise now and I had a complex custom legacy system that I was dependent on, I would seriously think about getting 3 or 4 teams started on replacing that legacy system with new generated code and see where we end up after 6 months, maybe 2 months, right?
So, Greg, you were talking about how large companies with multi-billion dollar systems have an option now to at least experiment and consider replacing those systems in a number of months rather than years and billions of dollars.
Yeah, I mean, I think as I contemplate that, if I was at a big enterprise now, I would be looking at standing up MCP servers that know how to talk to all of our various endpoints, and I would be looking to experiment probably with multiple teams as to how I would replace that, what used to be a multi-billion dollar system. And quite frankly, with these new capabilities, if it's on your books for a couple of $1 billion, it's probably not worth a couple of $1 billion anymore, right? Because the barrier to building a replica of it is now extremely low. And so the asset value of that thing that you spent maybe hundreds of millions of dollars building is evaporating rapidly because it can be replicated in a matter of weeks and months versus, years and tens of years. And so even at the enterprise level, I would be paying very close attention to this and pushing my teams to think about, how do I re-enter the question of these dependencies that I have on legacy systems in a new way?
So I may be able to drive massive business efficiency in 6 months rather than lots of years and millions and hundreds of millions of dollars.
Yep, that's exactly right. And we'll see this technology really get approachable even at the end user level. So I can imagine somebody who is tasked with entering data, similar data into multiple systems, being able to even write their own little code, even though they're not writing code, they're just talking to an interface and saying, hey, I need to be able to get this same data into 2 systems at the same time. Can you write me a little snippet of code that'll run on my local workstation that will just do that for me? And the answer is yes, you can have that.
And
And there's entire business models that have been premised on this idea of workflow automation using AI. The problem is that, they generally were doing little snippets addressing little snippets of the problem. Like, I'm going to read this form off of the internet and I'm going to figure out what it's looking for. And I'm going to go look for the data in this system. And now you can bring that all together at a much, much more rapid pace.
And so pace of business transformation, if I want to remain relevant, I need to be engaging in this now, whether I'm a relatively small enterprise and especially if I'm a large enterprise.
Yeah, I mean, I think the pressure on big companies to deliver improved unit economics is going to be extreme. And I think the pressure on smaller companies to be more agile and to disrupt is also going to be very high, because the barriers to replicating what you do they haven't gone away. There's all kinds of barriers to being successful in a given business, and they haven't all gone away. But one pretty important and pretty expensive one has just gotten lowered pretty substantially. Your relationships still matter. Your culture still matters immensely. The quality of your leadership still matters immensely, right? The mindsets and the investments that you make in education still matter. It's just that there's this one historically very expensive and slow thing that is now way less expensive and way slow.
What I and what I hear then is the mindset of the leaders and their teams has to shift as well, because that taking on the mindset of a scientist is now crucial. And we've been talking about this for a long time. You and I have on our show, the most effective leaders have to take the mindset of a scientist and continually experiment. We've now hit a point where that's not nice, it's required.
Yes, and the old, sort of standing mentality that people in big companies have around IT or around the engineering function is going to shift, because it used to be, every time I ask IT for anything, it takes months and it's way over budget, right? That's probably not going to be true for very long anymore.
Well, and IT becoming a very different kind of business partner because it doesn't take months and cost that much money.
That's right.
What do you want our listeners to be thinking about as they are considering how to deploy this new kind of tools?
If you're a technology leader, you need to be learning about these technologies rapidly so that you can be a leader in your organization at leveraging them for the benefit of the company and the people that work there. If you're a business leader and not particularly technically savvy, learn enough about it that you can ask the hard questions and hold your technology leaders accountable for bringing this new capability to bear on behalf of your company. It's time, it's real, it's now. You've got to be working with it, or you will be behind the curve. And as I started, it's felt like a time compression. It's really a tipping point phenomenon, but it feels like time compression because it's converged very rapidly. And so if it feels like, wow, this is moving really fast, it's because it's converging really fast. And whether you're on the business side or whether you're on the technology side, you got to be getting on top of this fast.
Beautiful. Thank you very much, Greg. And to our listeners, the call to action, I think, is crystal clear. The pace of change has now hit the tipping point. And if you're not enabling your business to be successful, your business may not be. It is now yours to do. For the business leaders, partnering with your technology organizations to ensure that you're working collaboratively to enable these changes is also crucial. And I want to use this minute to also say our latest book, Innovative Leadership and Followership in the Age of AI, starts with 10 leadership mindsets and behaviors that I think are absolutely relevant to this conversation. We as leaders, our behavior and the way we think about leading must enable the agility for our businesses to be successful. So thank you, Greg.
Happy to be here as always.